Hey there. I'm going to try to take on day 5 of Advent of Code. I think this puzzle is more difficult than the previous ones. I mean, makes sense. I went ahead and took the liberty of reading this one in advance, and I hope no one minds I actually started to play around with the code just to double check some of my knowledge before hitting record. And we'll just see how things go. Let's go ahead and let me, for fruition, let me go ahead and read off the poem. Day 5, Supply Stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in the stacks of marked crates, but because of the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of these crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask which crate will end up where. And they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks and the rearrangement procedure, which will be the puzzle input. So, what makes this puzzle difficult, at least for me, is that we have to design some sort of data structure, some sort of way to hold this information, especially, at least in my opinion, in this setting, which in where I want to explain this to other people. Actually, going through the iterations themselves will be easier once we figure out how to tell the computer this drawing here. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates, Z on the bottom and on top. Stack 2 contains 3 crates from bottom top, M, C, D. Finally, stack 3 contains a single crate, P. So for one thing, order matters. Then the rearrangement procedure is given. So we're going to look at this step here. Move 1 from stack 2 to stack 1. That is, move 1 crate from stack 2 to stack 1. So what happened was we're going to take this crate, namely capital D, that 1 crate, move it on top of stack 1, which will put that capital D on top of NZ. In the second step, 3 crates are moved from stack 1 to stack 3. That is, we're going to move the D, the N, and the Z. But if you could think about how things are done in real life with a crane and crates, these are moved one at a time. So the D gets placed on top of P, then the N gets placed on top of D, then the Z gets placed on top of N. So these crates D, N, Z, all 3 moved, but we have to, thinking ahead, we have to reverse the order. Then 2 crates were moved from 2 to 1. Notice here it was CM, but once they move over to stack 1, it's MC. Once again, we have to reverse the order. Finally, 1 crate is moved from stack 1 to stack 2, and so that we have a final answer to be able to put back into the puzzle input webpage. What we're going to be asked at the end of part 1 is to make a string of the letters that appear at the top of each stack. Okay, so I hope no one minds. I went ahead and took some liberty of putting the information in the text file. I'm not going to work with the drawing directly in the text file. To be honest, I don't know how. And for the example, we'll try to imitate these 4 steps that we just saw. Okay, so let me show you what I have so far. Probably going to use tidyverse for the string R package. Like usual, I'd like to load in the example and then later on load in the input. Now, I'm going to create a huge matrix. And the reason being is because these quote unquote stacks, I want to be able to jump in between them but in a way where I could assign a arbitrary variable to keep track of the stack number. In matrices, that means I'm going to simply keep track of the column index. That's my main motivation. Now, at the start of the puzzle, because of the way the stacks move, I don't know how many rows I need. I don't know how high the stacks will get. In a worst case scenario, let me bring up the example again. In a worst case scenario, these 6 crates will all be stacked upon each other. So the worst case scenario is that I'm going to need space in my data structure to incorporate all 6 in a single stack. Namely, the number of rows I need is the number of letters that we start with. So 6. We have 3, so the number of crates is 6. We're going to do this over 3 stacks. And for this, at the start, what I'm doing is making a matrix. And let me show you what it looks like in the lower left-hand corner. I'm going to make a matrix with 6 rows, 3 columns. I'm going to fill in each spot with a simple dot or period for now, just to have something to look at, really. Now, what I'm going to do is hand code the initial setting. In stack 1, with the letters NZ, I'm going to split up those letters with our friend, the string split function. And I'm going to put those 2 letters in the first 2 spots of column 1. So here in the lower left-hand corner, the NZ on the top 2 spots of column 1. Similarly, DCM is going to go in column 2. And the letter P is going to go in column 3. So now this is my view of the example we have here. Let's see. Sorry, too many windows open. Okay. So the example is here. My matrix is there at the bottom left, and that's how I'm going to express everything. From there, what I wanted to do was double check if I understood my knowledge of how this puzzle works out. In context, that means how the crane moves the crates. So we're going to look at these, at least this first step here. And I want to move that 1 crate D to the top of Z. The way I'm envisioning this is here in the receiving column, stack 1, we're going to move the NZ down 1 in the rows to make space. So temporarily there's a little bit of redundancy with the letter N, but we're going to move the letter D over to this top left corner where the N is. And then we need to keep things tidy, move these letters C and M up to where the letter D is missing. So now we have this arrangement after the first set of instructions, and then we could proceed from there. In other words, so far I've hand coded the way the puzzle, the mechanisms work out. I just need to do this in more of a computer programming way, because in the puzzle input, you got to handle all of this. I should probably also note, thinking ahead, that some of these letters are duplicated. So we should have code that does not need unique letters. So once again, what I'm going to do is get a sense of how many instructions there are. In the example, there are 6 instructions. There should be 4. Let me double check my files. I think I forgot to switch this over to December 5th. That's what happened here. Yeah, okay. And now I want to see if I could do this all in a folder. So for step in 1 through number of instructions, we're going to take this instruction is going to be a string split of the puzzle input at this step, split on the space and this R thing here. So at the moment, this instruction here in the bottom left looks like this. I need to grab this number in the 2nd spot, this number in the 4th spot, and this number in the in the 6th spot. So num crates will be this instruction in the 2nd spot, and I'm going to want this to be treated as a number. The from stack similarly will be in the 4th spot. And the to stack will be in the 6th spot. So I just want to double check that. This instruction was that the num of crates is 1, from stack 1, to stack 2. There we go. So now I'm going to try to repeat what I did in the hand-coded section, but with this information here. So we got the to stack in these locations, the from stack in these locations, this is the number of crates plus 1. Gotta be really careful here. what I'm doing is if we're going to move three, say for example, if we're going to move three crates into a new stack, got to move the in the incoming call, got to move three spaces down. Just not quite sure which numbers put in here. That's going to be number of crates plus 1. And that's going to be the number of crates. So let's see here. If we're moving one crate over, the stuff that I had in rows 1 and 2 moved to 2 and 3. If we move 2 crates over, the stuff I have in 1 and 2 moves to 2 and 4. I think this is 2 times number of crates. I have a hunch I'm going to make this much more complicated. I should. So then we move that number of crates from a previous stack to the next stack. And then number of crates from 1 to, I don't know how many crates I'm going to need to move in the previous stack, so I'm going to go all the way to the end of the row. Number of crates. What I'm really worried about is the steps when we're moving multiple crates. So if what I probably need to do is something with M again, really. That's what I'm thinking of. So what I'm trying to do is get these numbers. If I have 6 rows here, 2 to 6 goes to 1 to 5. And I think I got it mostly correct. I intentionally left off one detail though. So I do have the 4 crates in stack 3 now. And then the M and the C just happen to be switched. I probably should explain the big thought process I just did. So starting from here, let's look at this in the lower left-hand corner again. What I did was, say if I wanted to move the N and the Z down by 1 unit, I actually grabbed everything from row 1 to row 5. And then I'm going to put everything in rows 2 to 6. That is, I had to know the maximum number of rows. I'm actually moving the entire column, not just the N and the Z. So that's why the code looks like this. Now, the detail that I forgot to mention or include so far is because the crates only move one at a time. Remember that there's a reversal of order. So for example, when we move the crates D and Z over from stack 1 to stack 3, the D moves first, then the N, then the Z. So one of the reasons I wanted to do this in a matrix representation is because that notion of proceeding one at a time can be handled with the reverse function. So if I was a better coder, I would have comments on everything. The first line of code here of importance in the for loop, allocate space into 2 stack. Then you move the crates as requested, and in particular, rev handles one at a time movement. In accounting, we call this last in, first out, when you have a switch in the order in your queue. And we'll move in the from stack. So if this all works out correctly, then I should have the example handled. C is at the top of stack 1, M is at the top of stack 2, Z is at the top of stack 3. For the puzzle, print the elves want crates at the top of each stack. Let me do this here in the console, see if I get it right. If I have matrix example and I'm grabbing the first row, looks like that. In R, let's see what happens if I just use the paste function. Nothing. If I use the paste 0 function, and if I use the collapse function parameter. That's how I'm going to get the CMZ together. So now my code spits out the answer, at least for the example. Now, the silly thing is, I need to do this for the puzzle input, but because I hand coded the initial part, I'm going to have to do that again for the puzzle input. So give me a bit while I figure this out. For my puzzle input, I have 9 stacks. And 1, 2, 3, 4, 5, 6, 7, 8 letters at most in each stack. So to give myself a lot of space, I'm going to put 8 times 7 is 8 times 7 is 72. There are 72 crates in the system. Now, usually I switch out the puzzle input, but I think what I'm going to do is so that my code makes a little bit more sense. I'm going to put these in the proper code blocks. And, well, I still have to hand code this thing. So you can see how I do this now. In stack 1, locations 1 through 8, I'm putting in the letters B, V, W, T, etc. In stack 2, I'm putting in the letters B, W, D. And if anybody's actually watching this video at this point, you could probably just fast forward a bit. So if I have all this correct, my matrix should match the drawing in the top right. Let me double check that. I'm going to call this matrix puzzle, actually. I'm going to do a search and replace here. Matrix exp. I'm going to call that matrix puzzle. And then matrix puzzle at the top should look like my puzzle input. Now, give me a minute to really double check that, because if I typed in any one of these letters incorrectly, I could get the answer wrong. Okay, I'm going to run the code, hope for the best. We got it. Sweet. Okay, let's see what horrors await for us in part 2. As you watch the crane operator expertly rearrange the crates, you notice that the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. This crane isn't a Crate Mover 9000, it's a Crate Mover 9001. The Crate Mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin moving in that configuration. However, the action of moving 3 crates from stack 4 to stack 3 means that those 3 crates moved in exactly the same order, resulting in this new configuration. I have a hunch my code might already work. So that's going to be part 2. We have already solved part 1. I'm going to go through the example here in part 2, and if I'm lucky, all I have to do now is remove the reverse command. Isn't that cool? And in the part 2 example, the answer was MCD, McDonald's. Sweet. And now for part 2, for the puzzle input, same deal. I just have to remove the reverse command, run the code, and got it. All right. I know that was a lot of index checking, and I hope that these videos are helping someone or just kind of giving you a sense of a simple computer programming process. All right. That felt good. I'll see you tomorrow.